Welcome back, geometry students, to another edition of Your Notes. These ones are titled 3-3, Deductive Reasoning. These are on the back of our notes from 3-2, Inductive Reasoning. And inductive reasoning was all about patterns. Deductive reasoning today is all about using facts. So what are the actual facts that are given to us? We get these facts, and the reason why we can use these facts is because of definitions or postulates or theorems. That's where we get the facts that we can use in deductive reasoning in geometry. So we use those facts to prove a logical conclusion. So another way to describe deductive reasoning is called using logic. This type of logic was made famous by a guy named Sir Arthur Conan Doyle when he wrote the books Sherlock Holmes. Sherlock Holmes used deductive reasoning. He would deduce things, and from that deduction, he would then have his case and he would prove things that happened, mysteries. All right, when we open up our foldable, then we see two kinds of deductive reasoning. One is a law of detachment. One is a law of syllogism. The actual names of these are not really important. You remember what the difference of, but how to use them and identifying the statement that you have and actually using the deductive reasoning from it. All right. So our first example for law of detachment, we have this statement: if a student gets an A on a final exam, then the student will pass the course. That is just a conditional statement. So if P, then Q. All right. Then the next thing says if a student, it says the student gets an A on the final exam. Well, we see here that the hypothesis matches the next statement we're given. So if the hypotheses match up, then we can draw the exact same conclusion. So I'm going to draw a circle around those, signifying that, hey, those are the exact same. Then I can draw our same conclusion. So if a student gets in on the final exam, then the student will pass the course. Make sense? Let's look at the next one. If two lines intersect, then they intersect at exactly 1 point. And it tells us that line AB intersects line AC. Well, that statement matches up with the hypothesis of my statement, so therefore I can draw the exact same conclusion. So if line AB intersects line AC, then I can say that line AB intersects line AC at exactly 1 point. All right. Last one. If two angles are congruent, then they have the same measure. And it says angle ABC is congruent to angle DEF. So since they're the exact same here in our hypothesis, I can draw the same conclusion that the measure of angle ABC is going to be equal to the measure of angle DEF. And here I write the measure of the angle is equal to because they have the same measure. Measures are equal, but actual angles are congruent. So if we see just talking about the angles are congruent, but these measures are equal. All right, the next type of deductive reasoning we use is that law of syllogism. So example A says, if the sun is shining, then it is a beautiful day. If it is a beautiful day, then we will go outside. Well, I can think of this first statement of my if P, then Q. The next statement starts with the Q, starts with the conclusion of the first statement. So then this one go if Q, then something else. Then we'll go outside. We'll call that R. So we go if P, then Q, and then if Q, then R. What I can do is I can cut out the middleman there. Since Q is both the exact same for the conclusion and also the hypothesis, I can go straight from the hypothesis of my one to the conclusion of my second. Okay, so here I can cut out it's a beautiful day since it's in both those statements and just say directly that if the sun is shining, then we will go outside. If the sun is shining, then we will go outside. All right, let's look at the next one. If two planes intersect, then they intersect in a line. If two planes intersect in a line, then they are not parallel. I'm going to leave this one to you. I want you to write down the conclusion you can make from this. This is also going to be on your WISC form today, and we'll go over this first thing in class. So see if you can use the law of syllogism to cut out the middleman there, go directly from the hypothesis to the conclusion of the second. Let's look at that third one. If a polygon is a triangle, then it has three sides. if a polygon has 3 sides, then it is not a quadrilateral. ABC is a triangle. So we can go back and look at this. Is there something that's the exact same? If a polygon is a triangle, then it has 3 sides. If a polygon has 3 sides, right there. Okay, this right here is saying the same thing. The conclusion of one becomes the hypothesis of second. We can cut that out and say that if a polygon is a triangle, then it is not a quadrilateral. Of course, makes sense. But with this next statement, then it says ABC is a triangle, so therefore I can conclude that ABC is not a quadrilateral. ABC is not a quadrilateral. All right, example number 3, we're going to give some statements and reasons. So we're using some facts here in these tables. It's given to us that angle 1 and angle 2 are supplementary angles. Well, from that, I can know that supplementary means that they add up to 180. 2 angles add to 180. And so the statement that I can make from that, the facts I know, is that the measure of angle 1 plus the measure of angle 2 is going to be equal to 180 degrees. And I need a reason for this. What reason can I say? And so on the front here we talked about these facts we have to give by definitions, postulates, and theorems. Well, why do you know that this is true? It's not just because your teacher told you that it's true. It's because somewhere it's written down as a fact. That's all that is taken from the definition. The definition of supplementary states this exact same thing. So we've already worked through these kinds of questions, but now we can go through and say I can make that statement based on the definition of supplementary. The next one says that U lies in the interior of RHS. See if you can understand what that's saying. U are in the interior of RHS, angle RHS. Okay, we want to make a statement from this. It also would be very beneficial sometimes to make a picture, draw a picture. So if I have angle RHS, and U are in the middle of it, this is point U. Okay, what statement can I make? I can connect H and U, and you can see this is very similar to something we've already done in the past. I can say now that the measure of angle RHU plus the measure of angle UHS is equal to the whole entire thing, the measure of angle RHS. Why can I say that? Well, there was something we did in the back in the day. It was called the angle addition postulate. So that's my reason to give that statement, the angle addition postulate. So we're going to look at our postulates and theorems we've been given in the past. We're going to look at definitions to draw conclusions, to make statements about geometry terms. But we can also draw conclusions based on the facts by using just logic. All right, don't forget your WSQ. Have a great day.